Hello. In this video we're going to attack linear systems, specifically systems of three linear equations. And here is our system. Normally it's written with a big bracket to indicate that each one of these equations has the value of x, y, and z are the same through these three equations. The technique that we use to solve these equations is to combine the individual equations to eliminate all but one variable, and that's how we would start. To start out, we're going to find a solution for either x or y or for z by combining those equations. We need to remember we need solutions for all the variables. So we're going to need an x equals and a y equals and a z equals in order to be completely satisfied that we have solved this system of three linear equations. So how are we going to start with these equations? Well, I look at these two equations. Let's call them equation A, equation B, and equation C, so that we can be clear about what we're talking about. If I take equation A and multiply it by 2. Now remember, you can multiply the entire equation by, if you multiply an entire equation by the same number, you have not changed the value of the variables, you've only changed the form of the equation. So I'm going to multiply the first one by 2, and that's going to give me, so I'm going to call that 2a, that's going to give me 8x plus 6y minus 4z equals 38. And now in equation B, I already have a minus 6y, so I'm just going to combine equation A and equation B, and I will be able to eliminate y. When I add these two together, y will drop out, and I will end up with 16x, 5z minus 4z, plus z equals 46. We still have a z though. So now, what I am going to choose to do, I need to eliminate y in a different set of equations. So this time, I'm going to start out with a, and as it's given, 4x plus 3y minus 2z equals 19. And then I am going to multiply equation C by minus 1. So let's just call that minus C. And so if I multiply it by minus 1, I'm going to get minus 7x minus 3y minus 4z equals minus 16. And we add those two together, and we have 4x minus 7x is minus 3x. The y's go out again. And then we have minus 2z plus minus 4z minus 6z equals 19 minus 16 is 3. So we now have these two equations that we've derived from our original linear system, and in each case, now we have two equations with two unknowns. And pretty much, I think you know how to solve that kind of a system, but when I look at this, I'm seeing plus z minus 6z. I'm thinking if we multiply this equation by 6, then we will be able to combine these and end up with our value for x. So let me turn the page so that we can get our first value of x. Our equations are 16x plus z equals 46, and minus 3x minus 6z equals 3. So I am going to multiply this equation by 6. I think we can call these equations D and E. So I'm going to do 6D. 16 times 6 is 96. X plus 6Z equals 46 times 6 is 276. And I don't have to do anything to equation E. I have my minus 3x minus 6z equals 3. They look radically different, but these are the answers we came out with. So we add these together, and z goes away, and now we're at a point where we have 93x equals, we add these together, 279, and when we divide 279 by 93, it turns out that x is equal to 3. If I'm your teacher, I will accept this as the answer, but the best answer is always to reduce your fraction to the lowest possible terms and just have a go. See if 93 goes into 279 before you report it in that way. It's much cleaner to know that x equals 3. So we have our first value, x equals 3. So now that we have a value for x, we're going to use one of our equations to discover a value for z. I'm going to put this value back into equation E, and so I'm going to have minus 3 times 3 minus 6 times z equals 3. So this becomes minus 9 minus 6z equals 3. And if I add 9 to both sides of the equation, then we have isolated z. 9 goes away. Minus 6z equals 3 plus 9 is 12. And z, here's an equation that you can immediately see how to reduce. 12 divided by minus 6 is minus 2. So we have our second value, z is minus 2. Please be careful to keep your values for x, y, and z separate. Now that we have a value for x and a value for z, we can use any of our original equations to find a value for y. Let's look at them and see which one looks nice. I think the first one looks nice, so we'll use A. And A was 4x plus 3y. 4x plus 3y minus 2z equals 19. And we have found that z equals minus 2 and x equals 3. So we're just going to plug those in. 4 times 3 plus 3 times y minus 2 times minus 2 equals 19. 4 3s are 12 plus 3y minus 2 times minus 2 is 4 equals 19. So 12 and 4 is 16, so we have 3y plus 16 equals 19. And some of you can see where we're going with this. We're going to subtract 16 from both sides. That will give us 3y equals 3. And here's perhaps the easiest imaginable equation. Y comes out with a value of 1. Now, if you wanted to test all of those, you could plug them into one of the other equations in the linear system and see if it makes the equation true. But this is the procedure for tackling a system of 3 linear equations.